Today I will start new chapter, that's EMI. EMI, electromagnetic induction. Now first topic is magnetic flux density and magnetic flux. Magnetic density, that's B, and magnetic flux. First of all, the definition of magnetic flux density. The number of magnetic lines of force passing normally through a unit area of a surface is known as magnetic flux density. The number of magnetic lines of force passing normally through a unit area of a surface is known as magnetic flux density or magnetic induction, same thing, magnetic flux density or magnetic induction, that's B. Now, to define the magnetic flux, same definition. The number of magnetic lines of force passing normally through total area of a surface is known as magnetic flux. The number of magnetic lines of force passing normally perpendicular to the surface through unit area, through total area of a surface is known as magnetic flux, that's phi. With the help of figure, so this one is any frame, these are the magnetic lines of force, the uniform magnetic field. Is uniform magnetic field B is any surface. Its area will be perpendicular to the plane. The direction of area will be in this direction. That's vector area. This one is B. In this figure, 1, 2, 3, 4, 4 magnetic lines of force passing through or crossing the surface. So here the flux will be 4. Now here magnetic flux is scalar quantity, but the magnetic flux density is a vector quantity. Here magnetic flux is scalar, but magnetic flux density, that's B, is vector quantity. According to the definition of magnetic flux, the number of magnetic lines of force passing through total area is known as phi, but through unit area it is denoted by B, magnetic flux density. So the relation between B and phi will be B and A. Here A is area of the surface. Now phi is scalar, B is vector, and A is vector area. Here A is vector area. Its direction is always given perpendicular to the plane outward. For example, the direction of vector area of the ceiling will be downward, and the direction of area of roof, that will be in upward direction, perpendicular to the plane. Now phi is, this one is scalar, it is vector, it is also vector, so we can write this one, phi will be B dot A, it's a dot product. Or we can also write phi will be BA cos of theta. Here theta is the angle between B and A, is the angle between B and vector area A. With the help of figure, suppose this equation 1, suppose this one is B, this is any surface, this is a magnetic field, uniform magnetic field, direction is upward. That's magnetic field intensity B or magnetic field B. Here any surface is placed in such a way. Any surface, then the direction of surface area that will be perpendicular to the plane, that's A vector. Angle between B and A, this one is theta, and the value of flux will depends on this angle theta also. From equation 1 it is clear that the value of phi depends on B as well as on A, on B as well as on A and also on theta. On changing the value of theta, phi will change. On increasing the value of theta, cos theta will decrease, so phi will also decrease. Here there will be main three cases. Case 1, if theta is 0 degree, it means B is parallel to A, then phi will be BA cos of 0 degree, that's phi will be BA maximum. Maximum flux will pass through this surface. Now the case 2, if theta is 90 degree, in this way this one is B and here is the direction of vector area A, this angle is theta is 90 degree, then phi will be BA cos of 90, because cos 90 is 0, because of cos 90 degree is 0, so phi will be 0. No flux will pass through the surface, it means minimum flux. Now the case 3, if theta is 180 degree, is in this way, that's the direction of B, that's the direction of A, this angle is 180 degree. Because of cos 180 is -1, so phi will be BA cos of 180, that's phi will minus BA, again maximum. In first case phi is BA maximum, and also in third case phi is minus BA, is also maximum. Now what is the difference between the negative sign and positive sign here? Here in first case phi is positive, and in second case phi is negative. Phi plus means outgoing flux and phi negative means it is incoming flux. For example, this is the surface, a charge is placed here, any magnet is placed here, or lines of force passing in this way. Suppose this one is any surface, it has two planes, upper plane and lower plane. The flux moving in this way, it is known as plus phi, outgoing flux. But the flux entering the surface in this way, it is phi, it is negative, incoming. flux. A magnet is placed in any surface. This one is north pole and this one is south pole. This one is any closed surface. A magnet is placed here. North pole and south pole. Magnetic lines of force begin in such way. These are the magnetic lines of force. It is known as plus phi and it is known as minus phi. Here net flux phi will be 0. Suppose so many magnets are placed in a closed surface, then net flux through that surface will be 0. Now unit of phi and B. Unit of phi and B. Magnetic flux and magnetic flux density. The SI unit of magnetic flux is Weber. Magnetic flux phi is Weber, denoted by the symbol WB. Because of phi is equal to BA, it implies that B is phi upon A. Phi is measured in Weber upon A means meter square. It is also known as Tesla, denoted by T. It means Weber upon meter square is also known as Tesla. These are the SI units of magnetic flux and magnetic flux density. Now CGS unit of phi is Maxwell. So because B is phi upon A, that will be Maxwell divided by centimeter square, also known as Gauss. The relation between the CGS and SI units, the relation between the units of phi and B in SI and CGS systems. One Weber is 10 raised to the power 8 Maxwell. Because of 1 Tesla is 1 Weber upon meter square, we can also convert this one Tesla, that will be 1 into 10 raised to the power 8 divided by 10 raised to the power 4. That's Maxwell divided by centimeter square. It implies that 1 Tesla is 10 raised to the power 4 Gauss. One example. A surface of area 10 raised to the power minus 2 meter square is placed in a magnetic field 5 Tesla. Find the maximum magnetic flux passing through the surface in Gauss. Now the solution. Surface area is A is 10 raised to the power minus 2 meter square. Magnetic field, that's B is 5 Tesla. To be found magnetic flux, that's phi. Because phi is BA, maximum flux, because phi is BA cos of theta for maximum flux, theta will be 0 degree. So phi maximum will be BA, or phi will be 5 into 10 raised to the power minus 2 Weber. Because Weber in CGS, the unit of phi is Maxwell, and 1 Weber is 10 raised to the power 8 Maxwell. So the value of phi will be 5 into 10 raised to the power minus 2 into 10 raised to the power 8. That's phi is 8 into 10 raised to the power 6 Maxwell. The answer. Example 2. In previous question, if the angle between B and A area, vector area, is 60 degree, then find the flux passing through the surface. Solution. Because phi is BA cos of theta, here theta is 60 degree, so phi will be BA means 5 into 10 raised to the power minus 2 into cos of 60. Cos 60 is 1 by 2, so phi will be 5 by 2 into 10 raised to the power minus 2 Weber, or phi is 2.5 into 10 raised to the power minus 2 Weber. The answer.